Okay, Assalamualaikum and salam sejahtera. Okay, so for this video, I'm going to giving I'm going to give you a lecture for the chapter 5, our final chapter in MEV321. Okay, it is about the automotive braking system, and so there are subtopic. So hopefully by the end of this video, I can cover everything from the friction and braking until the advanced braking system. Okay, so uh, before I get started about the introduction of brake system, I just want to remind you all the lectures that we have done from the chapter 1 until now. You can refer back using Microsoft OneNote here. So if some of you still don't know how to use the Microsoft Teams, how to access that Microsoft OneNote, okay, just go to your group in the Microsoft Teams. Let's say you are in the group K, so make sure you click on the class notebook here, and then the version of class notebook, this one is the icon for the Microsoft OneNote, will appear here in the browser. It doesn't matter if you use the Google Chrome or Microsoft Edge or Safari or Firefox and so on. I think there is no problem in loading this Microsoft OneNote here. Okay, but some of you have complained before. You have a problem with the internet. So maybe some of you cannot open the online versions here. Okay, so what you have to do, you click on this one, open in browser, and click on the open in desktop app. So if you are using the laptop or PC that have Microsoft Office, so uh, uh, desktop version of Microsoft OneNote should be already in your PC or your laptop. Okay, but at least make sure you are using the Microsoft Windows. So for the latest version of Microsoft Windows, there are already built in with the OneNote here. So just click on the Open in Desktop app here and give it uh, permission. Just click on Open OneNote button here, and you will have uh, the desktop version will open. Okay, after that, and then just click the section there, find under the lecture, teacher only lecture. Click on the lecture, and everything that I have given during the lecture will be appear here. Okay, so you can access any chapter before. So whatever I put the video or anything that I have given some extra information during the lecture also will be there. Okay, so make sure you are using this Microsoft OneNote to refer back what we have learned along this semester. Okay, just as your preparation for uh, our final test this incoming Wednesday, right? Okay, so uh, that's all about how to use the Microsoft OneNote. Okay, that is just a revision, just a reminder for you to use this Microsoft OneNote. So I hope whatever I did, whatever I write during the lecture, you can refer back. Okay, uh, it is better for you lah, easy for you to do the revision for the test. Okay, okay, so let's go back to the chapter 5 here. Um, okay, I know. I think every one of you already know what is the function of the brake. Function of the brake is to slow or to stop, and also to control your vehicles. Okay, and for the principles that is used in the braking system is based on the kinetic energy, is to converting into heat. So which the heat energy will be dissipated into the atmosphere. Okay, so we know energy conservation, any conservation of energy. Energy cannot be created nor be destroyed, but it can transform into another forms. Okay, so the kinetic energy from the vehicles that is in the moving during your driving in a motion, so that will be kinetic energy. Okay, so to stop your vehicle, so we need to convert the kinetic energy into some else of energy. So in this case, we convert it into the heat energy. Okay, so uh, by doing that, your car will eventually stop because the energy, kinetic energy that happen in the car, that exists in the car, will be converted into the heat energy, and so finally your car will become zero velocity, so it will completely stop. Okay, so that is the principle. And uh, we have some classification just to categorize uh, the automotive braking system in our industry. Okay, so we can categorize by type. There are two types: disc brake and drum brake. So we will discuss later. We will know what is the disc brake and what is the drum brake is. Okay, and then by the working medium, uh, okay, some system use the hydraulic, and some system use the pneumatic. Okay, we know that pneumatic is a compression of air or gas. Hydraulic is the compression of the liquid. Okay, and then by technology, we have the ABS, anti-lock braking system. For the modern cars right now, we have the ESC or ESP, or any that is equivalent to the system, electronic stability control. And we also have the regenerative braking system that convert back, recycle back the energy, recycle back from the braking system that produce the heat energy. We can use that energy uh, to recycle back into the electrical energy or any some form of energy that can be used. Okay, that can be used. That's what this is some of the uh, technology that is used in the hybrid system. Example of the hybrid car system. Okay, and it also by end use. So this is just the classification of the automotive braking system. So it is not very important for you to know lah. Okay, just a brief, okay, about what we are going to learn for today. Okay, so make sure everyone is ready right now with the notes. You can download it in the Microsoft Teams. I already uploaded there. Okay, so let's get started. Okay, by the type of the brake, we can categorize into service brake and parking brake. So service brake is just a normal brake that you would have a pedal in your driving compartment. You have the pedal brake, and then you depress the pedal brake, and you can slow down your vehicle. So that one we call it service brake. And for the parking brake, it is operated to park during your during your vehicle parking. Okay, so it makes sure your car will be completely stationary, and some of the vehicles use the foot pedals, some have the hand lever, and for the modern cars right now, some of them are using the electronic parking brake. Okay, so there is no hand lever and foot pedal anymore. They just click on the button on the parking brake, and the system will apply that parking brake, so to make sure your car will not move when you park your car and you leave your car in the porch or in the parking lot and so on. Okay, so this is two types of simple brake: service brake and parking brake. So every time I tell you about the service brake, so you know, okay, service brake is the brake that you press the pedal to slow down your car, and for the parking brake is where the system use when you park the car. So that's it, just an easy explanation of the types of brakes here. Okay, so uh, for the car, we need to apply the brake force on all wheels. So there are two wheels in the front and two wheels and at the rear. So to make sure we apply the braking force at every wheel. So to make sure your car will slow down and stop in a stable way. Okay, so if you just apply two in the front, the rear wheels there will keep moving, keep rotating, and it will give you some instability during your braking process. Okay, so that's why we need to apply all four wheels when you depress the brake pedal. Okay, so the simple operations here, uh, I just tell you, you have to remember that we only have two main components. Okay, one is the master cylinder and the other one is the drum or disc, either one, right? Drum or disc. Okay, so we have drum and we also have disc. So some cars have both, some cars have only drum, and some cars only have disc. So we have the master cylinder and the drum or disc. Okay, and the master cylinder is just a reciprocating pump. Okay, it will pressurize the hydraulic system. Okay, hydraulic system here, it use the brake fluid, brake oil or brake fluids. Okay, that you already did in your practical session where you do the brake bleeding. So you remove all the brake fluid. Okay, that one is the brake fluid that is used in the hydraulic system in our braking system. Okay, so when you depress the brake pedal, so you pressurize that liquid, that brake oil, brake fluid. Okay, and then it will convert the mechanical force from the brake pedal into hydraulic force, and then it will apply brake at the wheel. So brake at the wheels, either you have the drum or you have the disc, and that drum and disc will squeeze your wheel, your disc. Caliper will squeeze your disc, and drum will some have the shoe, okay, brake shoe, okay, to give the contact, and it will give the friction force to your wheels, so your wheels will eventually stop. Okay, it will reduce the velocity, and finally it will stop. Okay, so that is the principle, the basic one. Okay, and then if to make this explanation a little more easier to be understand, okay, let's watch this video.
Let's start by understanding two important braking concepts: kinetic energy and friction. Kinetic energy is the energy possessed by an object in motion. Take, for example, these moving blocks. Their speed and weight combined give them kinetic energy. A heavier block will possess greater kinetic energy. Similarly, a faster moving block will also possess greater kinetic energy. Now, it's important to note that energy cannot be created or destroyed. It can only be converted from one form into another. So, How do we slow our moving block once it's in motion? Well, we can convert its kinetic energy to heat using friction. But what is friction? Friction is the resistance an object experiences when one surface moves against another. As you can see, our block is now sliding along the floor, and friction is converting its kinetic energy into heat energy, slowing the block and eventually bringing it to a stop. A heavier or faster moving block possesses more kinetic energy. This means that more kinetic energy is converted to heat as friction slows the object. Now, let's take a look at a light vehicle braking system. At the front of our vehicle, we have disc brakes. They use calipers to squeeze a pair of brake pads against a brake disc, creating friction. The friction generated converts kinetic energy into heat, slowing the wheel. Some vehicles have disc brakes on both the front and rear wheels. But in our example, we have drum brakes. Drum brakes contain brake shoes. Friction is achieved by pushing these shoes against the surface of a rotating drum. Again, the friction generated converts kinetic energy into heat, slowing the wheel. Both disc brakes and drum brakes are controlled by a hydraulic system. When the brake pedal is pressed, hydraulic fluid is forced through hydraulic lines, activating the brakes. Rear brakes can also be controlled by a parking brake to hold the vehicle whilst parked and for assistance on hill starts. And that's the basics of a light vehicle braking system. Remember, vehicle brakes are safety-critical components, making a well-maintained braking system essential to all of us.
Okay, so that's an introduction video for you to know that basically the brake system is converting the kinetic energy of the car into the heat energy, okay, by the friction principle. Okay, so that video also show you there are two kinds of brake. We have disc brake and drum brake. So both of them will be discussed later in this video. Okay, so let's go to the next slide. Okay, the first and the main component of the brake, we have the master cylinder. The function of the master cylinder is to convert your mechanical force from the brake pedal that you would depress using your leg, and it will convert into the hydraulic, using the hydraulic system, convert into the hydraulic force. Then it will apply force to your final brake caliper or drum. Okay, caliper in this brake, and drum and rotating drum in your drum brake. Okay, so for the test, make sure you read everything in the notes, because the questions of your final test will be based on the notes here. So make sure you don't miss any information that found in the notes. Okay, so I have another video here that explain how the master cylinder works. Let's watch it. And if you have a problems to watch this video in my recording video here, you can refer the link in the Microsoft OneNotes. Okay, I already put it in the Microsoft OneNotes here, the links. Just click on it.
Cylinder. Rubber pin. The brake master cylinder is an important component of a vehicle. Brake master cylinders convert the force of the foot or fingers into hydraulic pressure. A brake master cylinder is almost always a tandem brake master cylinder that will be described in this animation. First, we will explain the brake master cylinder with compensating ports. This master cylinder has a reservoir tank which contains the brake fluid and a cylinder. Rubber piston cups are located in the cylinder. The rubber piston cups form brake circuits. Since there are two brake circuits, such a master cylinder is called tandem brake master cylinder. The ports of the master cylinder are located in the top part of the cylinder. The outlet ports for the brake lines, which are connected to the brakes, are located on the side of the cylinder. As soon as the driver depresses the brake pedal, the push rod pushes the first rubber piston cup over the compensating port. Consequently, pressure builds up in the first brake circuit. As a result, the second rubber piston cup is moved over the second compensating port and pressure builds up in the second brake circuit. Occasionally, brake lines can leak or snap. For this reason, split brake systems are mandatory in many countries. If one brake circuit fails, the second one still works. Passenger vehicles typically have either a front-rear split brake system or a diagonal split brake system. In the front-rear split brake system, the first brake circuit provides pressure to the front brakes. The second brake circuit provides pressure to the rear brakes. In the diagonal split brake system, one brake of the rear wheel and one brake of the front wheel are supplied by one of the two brake circuits. Portless master cylinders are used in conjunction with ABS. This type of master cylinder has no compensating port. Brake fluid flows into the cylinder through the breather port. The breather port provides the brake circuit with brake fluid when the intake valve is open. As soon as the valve is closed, pressure is being built up in the brake circuit and the vehicle is being braked.
Okay, so that's how the master cylinder control your hydraulic system, hydraulic pressure in your brake system. Okay, so it will detect when you depress the brake pedal, and it will pressurize the oil or brake oil. Okay, and then it will give the force on the brake. Okay. Okay, so that's how the brake master cylinder works. And if you want to memorize step by step and the detailed description about that for your test, so make sure you read everything here in the notes. Okay, in this lecture video, I just try to explain in easy words for you to understand, and after that you have to do or to learn by your own as a preparation for the test. Okay, and for the brake operations, normally we are using the hydraulic pressure mechanism. Okay, as we know in the fluid mechanics that you have already learned in the semester 3 or semester 4, I'm not really sure. Okay, we know that we can convert uh, a little force into a big pressure, okay, by using the hydraulic mechanisms here. So as an example here, if we put it 100 pound there, so if you put the apply if you apply the force of 100 pound here, so you also will get the 100 pounds 100 psi. If this is the imperial unit for the pressure, this is the imperial unit for the force, okay. So you will get the 100 per square inch. But if you increase the surface area, okay, in the pistons here, so you will get lower the pressure. So it depends on the surface area, the force, and the pressure. So vice versa lah. Because P equal to F over A, right? F is the force, A is the surface area here. So P equal to F over A. So if F is smaller, your pressure will get higher. Okay, I hope you still remember about that you already learned in the fluid mechanics. And if I'm not mistaken, it also have been taught during your SPM level. Okay, so that the same mechanism we use in our brake system. When you depress the brake pedal here, so it will give the force to the piston that contain in the dual master cylinder. So there are more complicated components in there, but for the brief mechanism here, for the simple mechanism here, we break the brake pedals, and then the force will be applied on the pistons. So piston will pressurize the liquid or oil here, brake liquid here, brake fluid, and then it will push the force along the tube line or brake lines here until it give the final force to the piston that found in your wheels. So if you have the disc brake, so it will push the pistons on the brake caliper and so on. So the brake caliper will squeeze. Dia akan squeeze. Dia akan picit awak punya disc brake. So akan berlaku friction, geseran, dan kinetic energy daripada tayar awak, pergerakan kereta awak akan bertukar, will be converted from the kinetic energy into the heat energy. Sebab tu disc brake tu akan jadi panas waktu kita brake. Okey, benda yang sama untuk yang tayar depan. So kalau yang tayar belakang pun sama, cuma brake line dia pergi ke tayar belakang lah. So macam itulah cara dia. Okey, jadi kita tengok video ni macam mana hydraulic brake dalam kereta kita.
Let's take a look at the components that make up a typical hydraulic braking system. We have the brake pedal, the push rod, the servo, the master cylinder, the reservoir, and hydraulic lines. The brake pedal transfers the mechanical force applied by the driver to the push rod. The push rod transfers the mechanical force applied by the brake pedal through the servo to the master cylinder. The brake servo or vacuum booster assists the driver by applying additional force to the braking system. The master cylinder converts non-hydraulic pressure from the driver's foot on the brake pedal into hydraulic pressure. When braking, pistons with seals and springs in the master cylinder create hydraulic force, which pressurizes the entire hydraulic system. Brake fluid returns to the master cylinder when pressure is released. The reservoir holds sufficient brake fluid to stop air getting into the hydraulic system. Finally, we have the hydraulic lines, which carry the brake fluid to the front and rear brakes. Now, let's take a look at the hydraulic system in action. Here we can see the wheels turning. Pressing the brake pedal extends a push rod through the brake servo and into the master cylinder. The master cylinder pressurizes the entire hydraulic system and forces brake fluid through the hydraulic lines. Releasing the brake pedal reverses the process. The hydraulic pressure on the entire brake system is reduced, allowing brake fluid to return to the master cylinder. A combination of seals in the caliper and springs in the brake drum then return the brakes to their original position, allowing the wheels to turn freely once more. Brake fluid travels through the hydraulic lines, applying pressure to the caliper or wheel cylinder pistons, which in turn create the friction force required to slow the wheels. And that's the basics of how a hydraulic brake system works. Let's take a look at the
Okay. So macam itulah cara secara generalnya macam mana hydraulic system digunakan dalam kita punya braking system. Okay. Jadi kita tengok kat situ, bila hydraulic liquid tu ataupun cecair tu sangat penting. Yang itulah untuk braking system kita panggil dia minyak brake bahasa Melayunya kan. So dalam bahasa Inggerisnya brake fluid lah. Okey, brake fluid dia datang dengan apa kategori dia dot. Okey, Department of Transportation ni adalah standard bagi brake fluid. Dia akan namakan dot 3, dot 4, dot 5. Okey, yang terbaru sekarang dot 5 lah. Yang sebelum ni biasa yang kita jumpa dekat kereta-kereta kita ni dot 3 dengan dot 4. Tapi yang awak buat dalam lab, automotive lab tu Wira kan, Gen 2 kan. So Gen 2 pakai dot 4 tak silap saya. Okey. Jadi dia jenis-jenis dia tengok kan. Dot 3 paling banyak pakai, most widely used. Dot 4 was developed for this brake system, which develop higher temperature than drum brake system. Okay, sebab tu Gen 2 kita pakai disc brake kan. Okay, sebab itulah dia pakai dot 4. Okay, dan kebanyakan kereta-kereta moden sekarang kebanyakannya pakai dot 4 sebab pakai disc brake lah. Okay, tapi yang terbaru sekarang ni kita ada dot 5 ni yang lagi moden, lagi latest. Okay, awak nak tahu pasal-pasal ni, ada cerita sikit kat sini. Sebab dot 4 bila dia lagi baru, lagi latest, dia boleh dia didesign, okay, disynthesize daripada silikon untuk absorb lagi tinggi temperature, untuk dapat sustain lagi tinggi suhu dekat disc brake kita. Okay, tapi dia tak boleh campur lah dengan dot 3 dengan dot 4. Tapi kalau dot 3 dengan dot 4 dia boleh campur. Okay, jadi problem satu lagi dekat dot 3 dengan dot 4, dia juga hygroscopic, maksudnya dia boleh absorb moisture. Bila absorb moisture, dia akan kacau dia punya nilai suhu didih, takat didih dia. Jadi bila suhu tu tinggi, sepatutnya kita design dia, contohlah kan 400 darjah Celsius baru dia mendidih. Tapi bila dia lama-lama, dia jadi makin turun dia punya takat didih, boiling point ni. So sepatutnya dia boleh tahan lebih boleh tahan sampai 500. Tapi mungkin bila dah lama tak tukar, dia jadi turun dia punya boiling point sampai dekat 400 ataupun 300, dia dah jadi dah takat didih. So apa yang jadi takat didih, so dia akan tukarlah vaporize. Okay, bila vaporize, kacau lah awak punya braking system. So tak boleh uh, tak boleh operate dah lah kita punya hydraulic tu. Okay, tu yang problem dia. Jadi brake fluid ni memang kena jagalah. Okay, kena ikut kepada maintenance booklet awak. Kalau kereta awak tu, kalau dia kata 10,000 ke 20,000 sekali, 30,000 sekali ke, 30,000 ni kilometer lah, 30,000 kilometer, awak kena tukar minyak brake. So tukar lah, sebab benda tu sangat penting, critical untuk awak punya safety. Okay, so itulah cerita pasal introduction of the brakes and braking lah, macam mana operation dia. So kita pergi ke subtopik 5.3, spesifik khas untuk drum brake. So 5.4 nanti pasal disc brake. Okay, kita tengok pasal drum brake. Okay, drum brake ni has a metal brake drum that enclose the brake assembly at each wheels. Okay, two curved brake shoes expand outwards to slow or stop the drum, which rotate with the wheels. So the brake assembly attached to a steering knuckle as a housing ataupun strut spindle assembly. Okay, ni dia punya tak apa jelas kan gambar dia. Okay, so kita tahu drum brake ni lebih simple dia, tapi dia punya maintenance agak murah compare dengan disc brake. Okay, saya ada video nak cerita pasal drum brake untuk awak lagi senang tengok. Okay, kita tengok satu video ni.
Let's take a look at the components found in a typical drum brake system. We have the backplate assembly, the brake drum, the wheel, and the wheel nuts. First, we will take a look in more detail at the brake drum and backplate assembly. Brake drums are generally made of cast iron, which conducts heat well and is slow to wear. The drum rotates on the axle and wheels, providing the friction surface when the brakes are applied. Next, we have the backplate assembly. The backplate assembly contains all the components required to operate the drum brake. Let's explore each of these components in turn. The backplate remains stationary and provides a fixed base for the other components to attach. Next, we have the brake shoes. Brake shoes consist of a steel frame fitted with friction material or brake lining. This material is bonded or riveted to the outer face of the shoe frame. There is a wheel cylinder. The wheel cylinder is connected to the hydraulic system and contains pistons which are forced outwards by hydraulic pressure when the brake pedal is pressed. Shoe retaining springs pull the brake shoe down onto the backplate, keeping it in position. A tensioning spring is fitted to the shoes. When the brake pedal is released, hydraulic pressure is reduced, allowing the tensioning spring to withdraw the wheel cylinder pistons and pull the brake shoes away from the drum. This allows the wheel to rotate freely once more. Drum brakes use a self-adjusting mechanism. The adjuster takes up excessive clearance created as the friction material on the brake shoe wears, reducing the return movement of the shoe. This effectively brings the brake shoes closer to the drum and maintains a consistent pedal feel and braking response. Finally, we have the handbrake mechanism. The handbrake cable enters the drum through the backplate and connects to the brake shoe lever arm. Cable, electronic, and hydraulic systems are found in handbrakes, but in our example, cables are used to activate the rear brakes. When the handbrake is pulled upwards, the cable is tensioned, forcing the brake shoes out against the brake drum. A ratchet in the handbrake maintains this tension until the handbrake is released. And that's the basics of a drum brake system. Let's start.
Okay. So komponen dia tadi kita tahu kita ada hub drum dia, kita ada backplate itulah kita ada punya lining, kita ada punya shoe, brake shoe tu kan. Okay, brake shoe tu yang akan buat friction dengan rotating drum tu. Jadi bila ada friction, yang tu yang jadi perlahankan awak punya tayar punya kereta. Okay, jadi dalam tu jugalah shoe tu, brake shoe tu pergi keluar tu maksudnya untuk expand, untuk outward lah, expand outward untuk bersentuh dengan drum tu. Okay, jadi yang tu bila awak tekan brake dalam kereta ni, bila awak stop tekan pedal tu, brake pedal, so kita tahu dia akan pergi ke servo akan pergi ke master cylinder. So master cylinder akan pressurize kita punya minyak brake. Lepas tu minyak brake tu lah akan pergi ke piston. Kalau tadi dia kata wheel piston kan untuk drum brake, wheel piston tu yang akan tekan awak punya brake shoe tu. Jadi brake shoe pun bersentuh lah dengan kita punya drum. Okay, jadi bila ada sentuhan, so antara shoe material lah akan menyebabkan berlakunya friction. Bila friction, dia akan perlahankan kita punya tayar dan perlahankan kita punya kereta lah. Okay, jadi ada satu lagi video pasal drum brake kat sini.
Drum brakes are usually used as rear brakes in automobiles. Let's go through the parts involved in the system, and see how it works in detail. Brake drum acts as the braking surface on the wheel side. Wheel hub, the part to which the brake drum and the wheel are attached to. Let's have a closer look with the wheel hub off. Backplate. This holds all the brake components together. Brake shoes. These will be pushed against the inner surface of the drum. The friction between the lining and the drum is what makes the wheels to slow down. Hold down spring holds the brake shoes towards the backplate. Retaining springs returns the brake shoes to its resting position. Wheel cylinder, the hydraulic part which pushes the brake shoes. Modern drum brake systems are self-adjusting, which means when the lining wears out, the system adjusts the brake shoes towards the drum. For that, the system uses a brake adjuster lever, adjuster spring. The wheel cylinder receives the force that we applied on the brake pedal. At the back of the wheel cylinder, there is an inlet port to receive the fluid, and a bleeder valve to remove air in the system. Let's have a look at the exploded view. The cylinder body, dust boot, pistons, piston cups, piston cup expanders, return spring. When force is applied on brake, hydraulic fluid pushes the wheel cylinder pistons, which pushes the brake shoes. This action creates friction between the brake liner and the inner surface of the drum, and brings the automobile to rest. The adjuster makes sure that the brake liners remain close to the drum as the liners wear down. As you can see, it uses a screw mechanism to increase its length between the shoes. Each time the car brakes while in reverse, the cog is pulled down by the pin to push the shoes against the drum. And that's how a drum brake system works. Stay tuned for more presentations from Autotech Lab.
Okey. Jadi sama juga lebih kurangnya video tadi kan, yang ceritakan pasal drum brake awak. So drum brake komponen antara paling besar dia drum brake tu sendiri, drum. Lepas tu backplate. Backplate tu lah yang tempat semua komponen-komponen bagi drum brake yang lain nak wujud lah. Okey, jadi dekat situ kita ada wheel cylinder. Kita ada ni yang auto correction punya spring lah. Okay, lepas tu confirm kita kena ada shoe lining tu, shoe and lining. Lepas tu adjust the spring yang tolong adjust balik kalau bila kita dah makin nipis kita punya shoe, so dia akan berubah sendiri. So make sure benda shoe ni akan selalu dekat dengan kita punya drum brake nanti. Kalau tak nanti kalau dia makin nipis awak nak kena tekan, asal tekan sikit je pedal brake tu. Sekarang kalau tekan banyak sampai tak, kita rasa macam makin kurang lah brake power kita. Tapi sebenarnya shoe tu masih lagi tebal. Okey, jadi itulah gunanya adjuster tadi. Nak make sure efektif lah kita punya shoe tu sampai dah betul-betul habis, barulah kita kena tukar lining tu seketul. Shoe dengan lining, okey. Lepas tu dia dua jenis lah, leading trail or non-servo drum brake. Satu lagi dual servo drum brake. So mechanism dia lebih kurang, cuma beza dia, kita tengok dekat apa yang beza dia. Okey, leading trailing tadi ataupun yang bukan servo lah, yang tak ada servo tu is used on the rear wheels of many front drive vehicles. Okay, rear drive vehicle usually have dual servo rear brakes. In dual servo brake, the action of one shoe reinforce the action of the other shoe. In a leading trailing brake, the action of one shoe does not affect the other. Apa beza jadi? Okay, kalau yang duo ni, dia akan reinforce juga, dia akan bagi juga pergerakan tu, action bila kita tekan brake tu kepada shoe lain. Yang kita tahu kita ada dua shoe kan, drum brake tadi kita ada dua shoe, satu sini, satu sini. Okay, opposite side lah. Jadi untuk dual servo, wheel assembly akan reinforce kedua-dua sekali. Sebab yang ni biasanya digunakan untuk rear wheel drive punya kereta. Sebab kita tahu rear wheel drive, tayar power dia pergi ke tayar belakang. So dia nak make sure nak jaga stability lah. Jadi dia kena dua-dua kena reinforce yang sama, force yang sama. Okey, untuk leading trail ni ataupun non-servo drum brake, yang ni biasa gunakan dekat front wheel drive, macam yang kereta biasa kita jumpa dekat atas jalan kat Malaysia lah. MEV ke, Sona ke, Saga ke, Alza ke. Dan kebanyakan kereta-kereta di Malaysia ni yang kereta biasa-biasa orang ramai pakai, kita akan pakai front wheel drive kan. So front wheel drive yang mana guna drum brake kat belakang, itulah biasanya adalah non-servo drum brake. Jadi bila kita brake, kita tahu ni adalah wheel piston. Wheel piston akan tolak kanan kiri. So dia tak ada, dia akan separate lah. Yang ni tak kacau yang belah kanan, tak kacau belah kiri. So dua-dua akan tekan. So kalau contoh ni nipis berbanding yang shoe dekat belah kiri, so yang ni akan jadi macam kurang efektif. Yang belah sini akan lebih efektif. Tapi kita kena ingat, kita tekan kat sini, yang bergerak tadi adalah drum brake. Yang ni fix So drum brake. Jadi kalau ni tak ada problem sangat, sebab power delivery untuk kereta front wheel drive dekat tayar depan, bukan yang tayar belakang. So tak ada problem dari segi imbalance of brake force lah dekat kanan ataupun kiri kat sini. Okey, tapi kalau untuk rear wheel drive, benda tu sangat penting. Sebab kita tahu power delivery dia ke tayar belakang. So dia nak make sure balance lah dia punya brake tu ke atas kedua-dua shoe and lining kan. Okey, sebab itulah dia panggil duo servo drum brake. Duo, ingat kedua-duanya, both. Okey, itu pasal drum brake. Awak nak tahu untuk test ke nanti, untuk jawab macam mana nak jawab ke, dia ada kira hafal lah ayat-ayat penting kat dalam ni. Okey. Kita rehat sekejap. Untuk video ni saya hanya stop sekejap lah, awak terus sambung lah. Tapi kalau waktu awak tengok video, awak boleh rehat sekejap, boleh pause ke, ikut lah kan, ikut kesesuaian masing-masing lah. Okey, jadi ada lagi perbezaan-perbezaan dekat sini, yang mana advantage, mana disadvantage. Yang tu biasa kemungkinan masuk dalam test. Jadi yang tu kena tahu juga. Okey. So, kita rehat untuk yang drum brake. Saya akan sambung dengan 5.4 sekejap lagi pasal disc brake. Okey. Okey. Subtopik 5.4. Okey, jenis yang kedua, selepas drum brake kita ada disc brake. Okay, so this is the second type of our brake system, our automotive brake system. Okay, and for sure for the disc, we must have a disc lah. Okay, and then we have caliper, and we also will have pistons. Okay, so normally we have three types of disc brake. Okay, fixed caliper, floating caliper, and sliding caliper. Okay, setiap bezanya nanti kita tengok, sebab nama dia sendiri pun kita tahu bila fixed ni yang tak bergerak lah, dia maintain position dia. Floating ni yang dia akan ikut pergerakan, and then sliding caliper ni dia lebih kurang macam floating, cumanya dia ada berbeza sikit dari segi guide dia, tak ada pin. Okay, so kita tengok macam mana dalam video ni, apa dia fixed caliper, apa dia floating caliper. Okay, so ni video pertama mengenai disc brake. Kita tengok dulu apa yang dia cerita ni.
你知道吗？这新年啊，我不怕吧唧吧唧了。
也不管你有没有呗。
Let's take a look at the components found in a typical disc brake system. We have the wheel hub assembly, the brake disc, the brake caliper assembly, the wheel, and the wheel nuts. The wheel hub assembly attaches to the chassis of the vehicle and holds the brake disc and wheel. A bearing inside the wheel hub assembly allows the wheel and brake disc to rotate smoothly. This vented brake disc consists of two round metal plates, inside which there is a metal venting system. Brake pads squeeze against the disc to create friction, slowing the wheel. Friction creates high levels of heat, but the venting system reduces this heat by helping to circulate air, cooling the disc. The brake caliper assembly provides the mechanism for squeezing the brakes against the brake disc. It typically comprises of a caliper body, carrier, and brake pads. First, let's look at the caliper body. When the brake pedal is pressed, pressurized hydraulic fluid pushes out the piston. When the brake pedal is released, the piston reverts back to its original position. Externally, an outer seal and dust boot protects the piston from dust and contamination. Next, we have the carrier, which is a cast metal frame mounted to the vehicle. It holds the brake pads and caliper body. Two slider pins allow the caliper body to slide back and forth as the piston moves. Brake pads squeeze against the brake disc and produce the friction required to slow the vehicle. At the back of the brake pad there is a shim, which is designed to reduce vibration and noise. Next, we have the steel backplate, which provides the rigid base for the friction material and solid mounting to the caliper piston and carrier. An underlayer, sandwiched between the backplate and friction material, bonds the two together and acts as a thermal barrier to stop heat being transferred from the pad to the caliper. Finally, we have the friction material, which is made from a variety of compounds designed to offer a combination of stopping power, longevity, strength and comfort. The brake pads are often held in place by springs, pins, or in our case, a clip. These accessories should always be replaced when brake pads are changed. Now, let's see how these components all work together. The brake pedal is pressed and pressurized hydraulic fluid enters the caliper body. Hydraulic pressure pushes the piston out, first forcing the inner brake pad against the inside of the brake disc. As this happens, the inner piston seal deforms. Now, the inner brake pad cannot travel any further, so hydraulic pressure forces the caliper body back along the slider pins, pulling the outer brake pad against the outside of the brake disc. When the brake pedal is released, the inner piston seal reverts to its original position, withdrawing the piston. Let's take another look at this again from above. Pressurized hydraulic fluid enters the caliper body. The piston pushes the inner brake pad against the brake disc. When the inner brake pad reaches the extent of its travel, the outer brake pad is then pulled against the brake disc, slowing the wheel. And that's the basics of a typical disc brake system.
Okay. Jadi kita tengoklah cara dia, macam mana dia operation kan. Kita ada caliper, kita ada pad, brake pad. Kita ada dalam caliper tu kita ada piston lah. Sama konsep piston ni untuk gerakkan brake pad tu, okay, ke arah disc. First yang dalam dulu akan rapat bagi friction dekat inner disc. Lepas tu bila dah tak boleh piston yang akan tolak caliper yang sini akan pergi lagi rapat yang belah sini. So dua-dua akan bagi friction lah dari dua-dua arah, inner and outer disc. Okay. Jadi sebenarnya disc ni ada dua jenis tau. Kalau awak tengok dalam katalog kereta ke apa, dia akan cakap ventilated ataupun vented disc. Tu yang biasanya untuk yang lagi performance lah. Dan ada solid disc. Biasanya kalau 4 tayar tu pakai disc brake, untuk kurangkan kos, vented disc dia pakai kat depan saja, sebab yang depan lagi penting. Lepas tu solid disc 2 tu dekat belakang. So biasanya 2 kat vented depan, 2 solid dekat belakang. Okey, tu jenis-jenis lah. Dan kalau yang biasa kereta yang mahal sikit ataupun brand yang pentingkan safety, biasanya dia akan letak 4 vented disc dekat 4 tayar. Okey, jadi kita tengok dah general mechanism lah, how typical of the disc brake works. So but we need to know more because we have 3 types of disc brake. One is the fixed, one is the floating, and then the final one is the sliding caliper. Okay, ni bla 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 dulu. Kita pergi ke fixed caliper disc brake. Okay, fixed caliper has piston on both sides of the disc. Some use 2 piston on each side. Others use 4 piston with 2 on each side. The caliper is rigidly attached to a steering knuckle or other stationary vehicle parts. Only the piston and pad move when the brake are applied. Okay, ni biasanya untuk nak dapat banyakkan piston. Biasanya ni kereta-kereta performance biasanya pakai fixed caliper ni. Okay, kita tengok video. Ada video khas untuk disc brake yang fixed caliper.
New Shell Helix Power 5W. Maximize engine power with the world's first carbon-neutral oil made from natural gas, following these practices. Choose performance without compromise. Get your free gift now.
Disc brakes are used in many modern vehicles. This type of brake is also often used in motorsports. First, we want to explain a disc brake with a ventilated brake disc. An important component of the disc brake is the brake disc. The brake disc is divided into two parts and has small holes for better cooling. Another component is the caliper. Here, a monoblock caliper is shown. The caliper has caliper pistons on both sides. Caliper pistons are made of gray cast iron, steel, aluminum alloys, or plastics. Brake pads are located on both sides. Brake linings used to be made of asbestos. After the harmful effects of asbestos fibers became known, plastics were used. Caliper pistons are controlled by brake fluid and sealed with the help of sealing rings. Brake fluid enters the channels of the caliper via a hydraulic connection. The caliper pistons on the opposite side are supplied with brake fluid via one or more channels. As soon as the driver depresses the brake pedal, pressure is exerted on the brake fluid. This pressure then presses the caliper pistons against the carrier plate, whereby the brake linings are pressed against the brake disc. To prevent continuous grinding, a minimum distance between brake lining and brake disc is required. This clearance should be approximately 1 millimeter. A monoblock caliper with caliper pistons on both sides is the exception on the road. More often, floating calipers are used for normal cars. Floating calipers have one or more pistons on one side. Floating calipers are cheaper than fixed calipers. The caliper piston is pressed against the brake disc by pressure, whereby the entire caliper slides backwards and presses the opposite brake lining against the brake disc.
Shopee What Deals is coming. Add to cart now and check out at 12 a.m. on 18th January and get up to 80% off.
Floating caliper brakes are used in many vehicles. This type of brake is also known as a sliding caliper brake because the caliper can slide axially. The floating caliper brake is composed of a caliper with a hydraulic connection through which the brake is supplied with brake fluid. The caliper is attached to the brake carrier. The brake carrier is rigidly connected to another component of the vehicle. The caliper, on the other hand, can slide back and forth. Two guide pins on the caliper serve this purpose. When pressure is applied to the caliper piston is axially displaced. When the pressure decreases, the caliper piston returns to its initial position. First, the caliper piston presses the brake pad against the brake disc. Since the brake disc is fixed, the brake pad and caliper piston cannot be moved any further. If pressure continues to be applied to the caliper piston, the entire caliper must slide backwards. Without pressure, the caliper and caliper piston return to their initial position. The brake pads must be supported during the braking process. This can be accomplished in several ways. On the one hand, brake pads can be supported on only one side. On the other hand, brake pads can be supported on both sides.
Okay, so kita nampak perbezaan floating dengan fixed. Okay, floating simple sikit, hanya biasa ada pakai satu piston je. Untuk fixed dia akan pakai banyak pistons. Okay, lepas tu fixed dia pakai mounting bolt. So dia tak bergerak lah sebab dia ada dua-dua piston belah, kedua-dua belah. So dia akan tekan dua-dua lah. Kalau yang floating hanya ada satu saja biasanya. Dia akan tekan dulu yang belah dalam, lepas tu yang belah luar akan tertarik lah, tertarik sekali selepas tu. Itu adalah floating. Okey, jadi untuk passenger car, normal car yang biasa, kita akan jumpa floating caliper lah. Okey, kalau awak nak yang fixed caliper, saya tak sure. Kita tengok kereta apa yang pakai fixed caliper ni. Contoh ada ranking. Oh, ni Brembo sendiri yang buat ranking. Okay, tahu Brembo ni brand yang antara paling famous untuk brake, sistem brake. Okay, kita tengok ada ranking dia cakap tadi. Nombor 1 apa sekarang? Confirm lah kereta supercar lah nombor 1. Lah, tak boleh nanti. Tunjuk je lah semua. Tengok nombor 1 ni. Nombor 11. Okey, nombor 1 saya rasa memang Bugatti Chiron kot. Oh, Porsche 911. Okey, fixed caliper kan? Betul tak? Berapa piston ni? dia pakai carbon ceramic brake disc. Disc ni tak pakai solid besi dah, tak pakai steel dah, terus dia pakai ceramic dah. Okay, ada dia cerita pasal berapa piston. Saya rasa 4 lah kot, kebiasaan dia. Okay, nombor 1 Porsche 911, Ferrari 488 nombor 2, Chevrolet Corvette. Okay, jadi kita tengok sini fixed caliper semua kereta-kereta mahal lah. Kereta-kereta mahal yang level performance car, supercar ataupun sport car. Okay, kalau biasa yang kereta yang dekat luar, orang biasa mampu, orang Malaysia yang mampu beli, orang normal, biasa kita akan guna floating caliper. Okay, ni Lamborghini Huracan nombor 13 Aventador, Ateca, Ferrari, BMW M4, Cooper, Opti. Okay, kalau kita performance ni, biasanya manufacturer akan terus pergi ke Brembo yang akan design untuk kereta ni lah. Okay, jadi kalau kereta biasa, yang awak selalu tengok kereta-kereta biasa tiba-tiba ada caliper Brembo, sebenarnya dia bukan tukar sistem caliper tu, dia hanya beli cover caliper. Kalau ada lah yang memang nak invest dekat brake dia orang tukar terus caliper. Tapi jangan tertipu juga, ada yang hanya tukar cover caliper saja Brembo. Tapi dalam tu masih lagi original punya caliper yang asal daripada kereta dia masa dia beli lagi lah. Okay, sebab kalau satu set nak tukar terus memang mahal lah. Mungkin sampai puluh-puluh ribu lah untuk Brembo kalau untuk performance punya ni. Okay. Jadi kita tahu tadi floating dengan fixed khas untuk performance. Dia memang tak bergerak sebab dia ada piston kanan kiri. Piston tu yang gerakkan pad untuk squeeze kita punya disc. Untuk floating hanya biasa satu piston sajalah. Dia akan tekan dulu pad yang belah dalam, lepas tu caliper tu akan tertarik sekali untuk tarik disc, untuk tarik caliper yang belah pad yang belah luar. Okey, jadilah squeeze, lengkapkan dalam dengan luar. Okey, tu pasal floating. Dan untuk sliding pula, beza dia sikit je. Sliding caliper disc brake is similar to the floating caliper disc brake. Both caliper move slightly when the brakes are applied. However, the sliding caliper slides on machine surface on the steering knuckle, adapter or anchor plate. No guide pins are used. So beza dia guide pin kat sini Key point dia guide pin. Okay, untuk floating kita ada guide pin. Untuk sliding caliper kita tak ada guide pin. Dia terus dia sambung terus ke steering knuckle. Lebih kurang macam fixed caliper juga. Fixed caliper pun terus kepada steering knuckle. Okay. Okay, jadi lebih kurang macam sliding caliper ni gabungan kedua-dua lah. Combination of floating and fixed caliper disc brake. Okay, lepas tu macam mana kita nak tahu bila dah nak habis lining untuk pad tu. Disc brake tu memang dia intentionally design to produce sounds, squeeze sound tu. Kan, awak dengar macam suara bunyi besi, tu memang khas when indicator dia ni bunyi tu. Jadi bila bunyi tu automatic dia tahu okey dah memang kena tukar brake pad. Okey, tukar pad brake sebab pad brake datang sekali untuk lining ni. Okey, awak tak boleh tukar, kadang-kadang ada lah yang boleh adjust tapi biasanya tukar seketul je. Okey, bukan seketul lah, dua ketul lah kan, dalam dengan luar. Kadang-kadang ada yang nak luar saja, dalam saja, ada yang nak luar juga saja. Tapi kalau bila dah bunyi tu biasanya dia wear dia tu waktu yang lebih kurang sama lah. Kalau awak tukar dulu yang luar, nanti tak lama sebulan 2 bulan pula belah dalam, tukar dua-dua seketul. Dua-dua ketul terus, dalam dan luar. Okey, tu pasal disc brake. Lepas tu kita pergi ke 5.5 pasal parking brake. Yang ni saya nak laju sikit. Okey, function of the parking brake. Kita tahu tadi kita ada dua jenis kan, service brake dengan parking brake. So parking brake ni ada yang pakai kaki. Ni biasa kereta-kereta MPV dulu-dulu. Ataupun Pajero dulu, macam mana tinggal. Parking brake kat kaki juga kot. Okey, lepas hand lever ni yang biasa kat kereta kita jumpa, kereta hand lever. Yang sekarang ni yang moden pula kebanyakan pakai electronic parking brake pula dah. Beza dah. Okey. Jadi untuk yang mana dekat belakang, kita tahu parking brake ni dia hanya kunci tayar belakang. Okey, jadi untuk rear drum brake dia terus kunci kita punya shoe tadi. Okey, dia ada kat sini ni parking brake lever yang ni. So dia terus kunci. Dia pakai macam tali. Okey, tali kita angkat handbrake kita tu kat dalam kat awak tengah memandu tu kat sebelah kan, kat tangan tu. Kita angkat handbrake. Sebenarnya kita kunci benda ni, kita angkat. So terkuncilah tayar belakang sebab shoe kita ni akan terus tekan kita punya drum brake. Jadi tak boleh nak bergerak lah. Sebenarnya boleh bergerak juga bila dah terlalu kuat sangat. Tapi ni macam 100% dah terkunci terus. Okey. Tu kadang-kadang orang nak elakkan kereta kena towing. Contoh awak parking reverse. So kalau towing tu angkat kereta awak dari depan, so tetap tak boleh tarik sebab tayar kereta belakang awak terkunci. Sebab tu kalau dengan towing ke, orang yang nak mencuri kereta dengan towing ke, dan kat tayar belakang senang. Tapi kalau sekarang ni dah electronic parking brake ke apa semua, lagi susah jugalah. Tapi bila nak mencuri ni macam-macam boleh buat kan. Okey. Lepas tu untuk rear disc brake, awak baca kat sini. Saya nak skip laju sikit parking brake ni. Yang ni yang independent lah. Okey. Kalau sekarang ni ada electronic parking brake, kita tengok macam mana dia berfungsi kan. Biasa banyak kereta sekarang dah pakai electronic parking brake.
Every day pulling away on uphill slopes often leads to unpleasant situations. If the car behind pulls up too close, rolling back slightly could be all that is needed to cause minor but costly damage. After having applied the brakes, the driver can take their foot off the brake pedal. The vehicle is secured and cannot roll back. All the driver has to do is press the accelerator. The assistant takes care of the rest on the uphill slope.
Okey, video ni hanya nak tunjuk pasal hill assist. Sebab hill assist tu dia akan datang sekali dengan electronic parking brake lah lebih kurang. Sebab hill assist tu dia tolong brake kan untuk awak waktu tengah atas bukit kan, waktu nak bergerak daripada kedudukan inclination, ada angle tu, angle naik bukit. So sepatutnya kalau kita belajar dulu, kita angkat hand lever lah. Kita angkat dulu parking brake dulu, kita tekan dulu minyak, baru kita lepaskan parking brake, baru dia boleh pergi ke depan, dia tak mengundur ke belakang. Okey, tapi bila dah moden sekarang ni, kebanyakan sistem dah ada hill assist. Dan hill assist tu biasa dia akan integrated sekali dalam dengan parking brake, electronic parking brake. Okey, banyak kereta dah pakai electronic parking brake. Dan dia akan ada auto hold. Auto hold tu maksudnya dia tolong brake untuk awak waktu awak dalam traffic jam. Awak tak perlu lagi dah tukar kepada gear neutral. Awak terus tekan sekali, lepas tu dia auto hold, awak lepas je brake tu. Lepas tu bila nak gerak balik, awak tekan minyak je. Tu auto hold. Lepas tu bila dah semua elektronik, dia bolehlah integrate sekali dengan autonomous parking ataupun automatic parking pula. Autonomous brake. Maksudnya dia tolong brake untuk awak kalau dia detect ada kereta kat depan tapi awak masih lagi tak brake. Jadi dia tolong brake kan untuk awak. Ni maksudnya emergency brake lah, auto emergency brake, autonomous emergency brake. Okey, benda-benda tu AEB yang biasa dia panggil, autonomous emergency brake. Biasa kebanyakan kereta tu yang ada benda-benda safety tu biasanya kena integrate sekali dengan electronic parking brake. Okey. Jadi tu pasal parking brake. Dan last subtopic kita cerita pasal advanced braking system. Jadi banyak dah sekarang ni. Mungkin ada yang tak cover dalam kita punya syllabus. Dalam ni dia cerita pasal vacuum brake booster, hydraulic brake booster, dan ada sikit pasal ABS. Sebenarnya selepas tu lagi banyak dah kita punya sistem. Kalau awak nak tahu cara brake untuk kereta electric car, EV, dah lain dah. Awak lepas je pedal minyak, dia terus brake. Tu electric vehicle. Okay. Sekarang ni untuk yang internal combustion engine punya kereta, brake masih lagi kena tekan pedal lah. Kena tekan pedal brake tu. Okay, jadi kita cerita ni ada dua jenis power brake. Vacuum brake booster, hydraulic brake booster. Okay, most vehicle have power assisted brake or power brake. Only a relatively light pedal force is required to slow or stop the vehicles. This assist is provided by either a vacuum brake booster or hydraulic brake booster. Both types allow normal, unassisted braking if the engine is off or if the booster fails. However, the driver must then push harder on the brake pedal. Okay, sebenarnya ni memang terguna pakai dalam hampir semua kereta yang ada sekarang. Okay, awak nak tahu beza dia. Bila contoh kita engine mati, so power brake tak on lah, tapi kita masih lagi boleh brake kereta kita, tapi awak kena tekan dengan kuat pedal tu. Okay, tapi bila waktu power brake on, waktu engine hidup, jadi ada motor. Kalau untuk hydraulic brake booster, dia ada motor dia, pump dia, dia tolong assist, dia tolong. Jadi awak hanya boleh kena tekan sikit je brake tu, dia dah tolong kuatkan, pressurize kita punya hydraulic pressure dalam kita punya brake system lah. Okay, tu beza dia. Jadi ada dua jenis, vacuum brake booster dengan hydraulic brake booster. Okay, kita tengok apa ni. Oh, ni video pasal jenis-jenis teknologi baru lah. Ni bukan saja baru, dah lama dah. Tapi kereta-kereta sekarang yang normal biasa, yang kereta biasa pun dah pakai dalam sistem kita. Ni saya boleh kata MEV baru ke, Alza baru ke, Arus baru pun, ataupun Proton pun, hampir semua ada kat benda-benda ni. Okay.
A few years back in 2017, during a business trip to Japan, I had a chance to have...
Starting with ABS. Consider its looks, power, and torque figures. When you look at a car, you generally consider its looks, power, and torque figures. It's probably safe to assume that most of us spend very little time thinking about a car's braking ability, and undoubtedly many of us barely considered what a car will do to help in an emergency stop. You may have seen ABS, EBD, or BA mentioned somewhere in a brochure or a car advertisement. These are all the cutting-edge car braking technology. ABS known as anti-lock braking system. EBD as electronic brake force distribution system. And BA known as braking assistance. Almost all of us are aware of such terms, but only a handful knows what exactly they mean, and how exactly they strengthen the safety department of a vehicle. Their functionality is completely different from that of the regular brakes, and these are considered much safer for the occupants. These features are present in a number of vehicles from the hatchback, sedan, compact SUV, and multi-purpose vehicle segments of the domestic market. So let's understand these topics differently, starting with ABS. As the name implies, ABS prevents the wheels of the car from locking up when the car applies the brakes suddenly in certain situations. This type of brake allows the driver to have complete control of the car's steering when maximum force is applied to the brake pedal. Generally, when the driver suddenly applies brakes to a moving car, there is a high probability that the wheels will get stuck due to the sudden brake force and slide on the road. This happens because the momentum of the velocity of the car is carried by it, and the wheels are unable to convert it into rotational motion due to the brakes. ABS, or anti-lock braking system, is a piece of safety equipment that prevents the wheels of a vehicle from locking up under emergency, panic, or harsh braking conditions. When braking on wet surfaces during rains, you tend to depress the brake pedal to its full limit and eventually end up locking the wheels. At this point, your car starts sliding straight without directional control. The situation becomes worse when all this happens uncontrollably. The loss of grip may result in the driver losing control over the steering of the vehicle. This may, in turn, lead to an accident. That's where an ABS comes to the rescue. Thanks to the latest safety regulations, nearly all 4- and 2-wheelers nowadays come with an ABS. The first primitive form of ABS was developed in the 1920s by French pioneer Gabriel Voisin, initially to aid braking on aircraft. Although, it wasn't until the 1970s that ABS was adapted and introduced to the commercial vehicle market on a large scale. The anti-lock braking system has four main components: speed sensors, valves, pumps, and controller. Speed sensors monitor how fast the wheels are rotating. Valves allow to block and release pressure on the brakes. Pumps are filled with hydraulic fluid and apply pressure to the brake drums on demand. The electronic control unit, ECU, is the brain of ABS and uses data from sensors to determine whether to pump the brakes or not. The speed sensors are located on the wheels that monitor the speed of each wheel. When sensors detect that your car's tires begin locking up, the electronic control unit reads the signal from each sensor and sends the signal to the valves of the respective wheel. Then, valves rapidly apply and release the brakes automatically to keep your tires from skidding and helps keep the driver in control of the vehicle. If speed sensors detect that the speed of any of the wheel is reducing drastically compared to others, the ECU sends the signal to the valves of the respective wheel to reduce the brake pressure, and the valves get closed. After this, the wheels start to accelerate again, and the signal is sent to the ECU one more time, which in turn sends the signal to open the valve and increase the brake pressure, and hence, brakes are applied. The cycle repeats itself until the application of brakes becomes normal. So essentially, ABS works in three stages. Brake pedal is pushed. Will sensors detect skidding or locking, ABS pumps the brakes. In a car equipped with ABS, what mostly happens is the system applies the brakes in small pulses to prevent sudden brake locking. That is why you can feel vibrations and juddering at the brake pedal when ABS is activated. When you feel or hear the ABS vibrating, continue to firmly press and hold the brake, then steer to safety. If your car doesn't have four-wheel ABS or the ABS is not working, you'll need to slow your vehicle down as much as possible before turning the steering wheel. Take your foot off of the accelerator pedal, and if you're in a manual geared car, push the clutch down, push the brakes with as much pressure as you can, until you can feel your wheels lock, then release the brakes, take your foot off the brakes, then reapply the brakes. This replicates the ABS braking method. ABS works most effectively when the tires are properly inflated and in good condition. Common causes of four-wheel ABS malfunctions include worn brake linings and air or dirt in the brake fluid. The primary task of ABS is to give the driver steering control during hard braking, not reduce stopping distance, as is the general misconception. That said, given the right type of road and conditions, that may prove to be the case. For example, on wet sealed roads ABS usually shortens the distance required for a stop, but on gravel or dirt tracks, skidding may actually decrease stopping distance as the car's tires are able to dig into the surface. Besides the ABS, there is also the EBD, which stands for Electronic Brake Force Distribution. While ABS is the overall automotive braking technology, EBD is just a part of the overall system. However, both these elements are equally important in reinforcing the safety department of the vehicles. The EBD is responsible for distributing the braking power to all wheels of the car. Also helps in regulating and applying the braking force needed to each wheel according to the road condition, vehicle's load, and its speed. The EBD ensures how much braking force is needed by each wheel, and then applies the same in order to achieve the most suitable braking impact. For example, consider the most common scenario. In a front-engine car, front wheels carry a heavier load than others, and will require more brake force in order to bring the car to a stop, without it going out of control. The extra weight up front increases the grip of the front tires, while it reduces the grip of the rear tires. This makes the rear tires more likely to lock up during braking. When the rear wheels slip, the car can begin to fishtail or even go into a spin. Traditionally, braking systems included a proportioning valve to allocate the correct amount of brake force to the front and rear tires. However, with ABS, the proportioning valve no longer provides an ideal solution to the problem. EBD is based on the principle that not every wheel needs to put forth the same effort into bringing the car to a stop. That means an EBD system can not only detect how much weight is being supported by each wheel, but change the amount of braking power sent to each wheel on an instant-by-instant basis. When a car slows down, its weight shifts forward. In a front-engine car, this is where the EBD comes in. With EBD and ECU determines the slip ratio of each of the tires individually. If the ECU notices that the rear wheels are in danger of slipping, it applies less force to them while maintaining, or, if necessary, increasing, the force applied to the front wheels. EBD is also useful when the car is braking while driving around a corner. While turning, the outer wheels of the car rotate more quickly than the inside wheels. If too much brake force is applied to the inner wheels, they can lock, causing the car to oversteer and go out of control. EBD can sense the slippage of the inner wheels and reduce the brake force on those wheels, without reducing the force on the outer wheels. A number of vehicles, such as Honda, Volkswagen and Nissan cars have these features as standard. The same can be inquired through the Honda or Nissan car dealers while purchasing the particular models. An EBD system makes use of three components which make it tick: the speed sensors, brake force modulators, and electronic control unit, ECU. The speed sensor not only calculates the speed of the car, but it also calculates the speed of the engine. One of the scenarios can be that the speed of the wheel might not be the same as the speed of the car. Such a situation can lead to the wheel skidding. The speed sensors calculate the slip ratio and relay it to ECU. Electronic control unit. It is a small chip which collects the data from the speed sensors in each wheel and uses the data to calculate the slip ratio. Slip ratio is the difference between the speed of the car and the rotation of the tire. Once the slip ratio is determined, it makes use of the brake force modulators to keep the slip ratio within limits. Brake force modulators. It is the job of these modulators to pump brake fluid into the brake lines and activate the brake cylinders. The brake force applied on each wheel can be modulated. All these three components work in tandem and make the EBD work and save your day every time you brake hard.
Let me please introduce our
Brake Assist, BA, is also known as Emergency Brake Assist, EBA, is another piece of car braking technology. As the name suggests, is responsible to assist the driver in emergency stop situation. The braking system will work more swiftly when there is sudden braking, if it is equipped with the BA feature. This feature, aimed at making sure that the brakes are applied in case of an emergency, if the driver is unable to respond quickly enough. This happens a lot, that in case of sudden braking, the driver is not able to press the brake pedal fully. However, an average driver isn't actually fast enough for a situation like this, where a millisecond of delay can translate to catastrophe. This is where braking assist steps in. With brake assist, the electronics sense the speed and force with which the driver pressed on the brake pedal, and apply additional pressure on the pedal for full braking. A travel sensor attached to the brake pedal that allows the brake assist system to detect when the driver attempts an emergency stop, and regardless of the amount of pressure actually applied, it will apply maximum braking force until the car is brought to a stop. Some more recent braking assistance systems can detect a sudden liftoff from the gas pedal, or receive imminent crash warnings from radar or camera-guided crash detection systems and prime the braking system. That way, when the driver slams the brakes, maximum braking force is available immediately. This system works with the three main components: accelerator sensor, brake sensor, and electronic control unit. Let's consider an event of normal braking. During such event, driver lifts off foot from accelerator and presses brake pedal. The same actions are performed even in the case of emergency braking, but with greater intensity. ECU measures this intensity with the help of inputs from accelerator and brake sensors and determines whether driver has encountered an emergency. If it is found that the braking is due to an emergency, then ECU orders the brake booster, a component of brake system that can control pressure of braking, to apply more pressure on brakes so that vehicle could be brought to a stop early. Of course, the system takes care that the pressure applied is always optimum. Undoubtedly, this system is very useful in reducing the stopping distances during emergencies, as it applies optimum brake force almost instantly. Also, this system has helped saving many lives by avoiding accidents. Mercedes-Benz is the first manufacturer to offer this system as a standard feature on all its vehicles since year 1998. So what do you think about these braking systems? Are they good? What braking system do you drive a car with? Tell me in the comments. Did you know that there are many different types of tires available which differ according to the season? Watch this video and find out which tires are best for you.
Okay, video tu boleh tahan juga lama, 12 minit, tapi dia detail lah, dia cerita pasal ABS, EBD dan BA. Kebanyakannya kereta moden sekarang yang awak, kalau contoh nanti awak nak beli, mungkin dalam lepas awak kerja ke apa semua, kalau boleh at least kena ada ABS lah. Tapi kalau sekarang ni kebanyakannya yang wajib ada ABS dengan EBD. Untuk BA ni brake assist ni ataupun emergency braking system ni, ni kena tengok jenis model lah. Kalau macam Azia saya rasa tak ada lagi, tapi kalau MEV baru, Arus, Alza semua dah ada. Kalau Proton pun, kalau X70, X50 semua memang semua ada lah. Kalau Iris ke Persona ke Saga, rasanya dia ada ABS dengan EBD je. Jadi kalau kereta yang tak ada ABS untuk dunia moden sekarang, bagi saya jangan belilah kereta tu. Melainkan kereta tu second hand. Kereta second hand tu zaman dia mungkin tak letak lagi. Tapi kalau yang kereta baru, elakkan lah. Cuba kumpul duit dulu, make sure safety first. Cari yang kereta yang selamat. Okay. So pasal tadi vacuum brake booster, dia tak cerita lah kan. Okay, many vehicle use a vacuum brake booster that has a single diaphragm. Okay, depressing the brake pedal cause the brake pedal push rod to move the air valve away from the floating control valve. Air at atmospheric pressure flow past the valve and into the space between the piston and rear housing. Okay, this forces the diaphragm and master cylinder push rod toward the master cylinder. As the piston move into the master cylinder, braking result. So ni sebenarnya nak menyenangkan, nak senangkan driver untuk tekan brake lagi cepat dan lagi tak perlu tekan banyak, tak perlu tekan kuat. Okay, ni salah satu dia cara dia operation macam mana vacuum brake booster digunakan. Okay, jadi vacuum brake booster ni tak perlukan external power, tak perlukan kuasa. Dia tak ni lah. Tapi kalau okay, ni cerita detail lagi. Okay, untuk hydraulic brake booster pula, hydraulic pressure supplied by the power steering pump provide the assist to apply the brakes. Okay, yang ni dia kena pakai active power, maksudnya ada external force. External force tu datang daripada steering pump. Okay, kita tahu pump kita power steering kan. Power steering pump kan kita dah belajar, kita ada pakai hydraulic, kita ada pakai campuran lah, mechanical dengan electric, dan ada yang pakai fully electric pump. Okay, jadi kita pakai je power pump tu untuk tolong kita punya brake. Okay, sebab tu setengah kereta yang combine dua ni, dia pakai minyak power steering sama dengan minyak brake. Dot 3 ke dot 4 ke, sebab dia guna sistem integrated sekali untuk pressure ni, untuk booster ni. Okay, jadi tugas dia, when the engine is running with the brake release, pump pressure goes to the steering gear. Okay, kalau kita tak tekan brake lah, pump pressure tu dia akan guna untuk kita punya steering lah. Okay, pushing down on the brake pedal force, the brake pedal push rod slightly forward. A pivot arm or lever connect the booster input rod to the spool valve. Yang spool valve ni yang pergi ke kita punya brake. Jadi lepas tu dia akan tolong lah. Dia akan guna ni, as a movement of brake pedal forces the spool valve forward, this send additional pump pressure into the space behind the power piston. The increased pressure move the power piston forward. This push the master cylinder push rod into the master cylinder with a greater force than applied by the driver. Okay, faham tak? Maksudnya waktu biasa normal, kita tak tekan brake, pump ni, hydraulic pump ni digunakan untuk gerakkan rack and pinion awak steering. Okay, jadi awak ringan lah, bukan power steering kan. Okay, tapi bila awak tekan je brake, so dia akan gerakkan pivot arm untuk sambung ke spool valve. Lepas tu jadi terbuka lah spool valve. Hydraulic oil tu akan pergi pula untuk brake. Jadi dia tolong tekan pula brake master cylinder tu. Dia tolong master cylinder. Jadi awak akan dapat force yang lebih berbanding awak tekan tanpa hydraulic brake booster ni, tanpa bantuan hydraulic daripada steering pump tu. Okey, tu konsep dia. Jadi yang lain awak boleh baca detail kat sini lah. Okey, yang ni dah tunjuk tadi, disc brake caliper silap kat sini. Ni tak perlu kat sini lah video ni. Kita delete dulu. Okey, jadi kita dah tengok macam mana ABS, anti-lock braking system, dia digunakan untuk elakkan terkunci tayar kita waktu kita tekan brake dengan kuat waktu emergency. Sebab kalau dulu bila kita tekan brake, tayar akan lock. So lock, awak tak boleh nak steer dah. Jadi sepatutnya kita ada masa untuk kita elak, untuk pergi kanan, pergi kiri, untuk elak halangan kat depan tu, untuk elakkan accident. Tapi disebabkan terkunci tayar, kita tak boleh steer, jadi kita terlanggar direct. Okey, jadi tadi dalam video tu dah tunjuk macam mana anti-lock brake tu, dan awak pun dah pernah buat dalam praktikal. Saya tak tahulah awak faham ke tak waktu dalam lab. Kita tekan. So bila kita tekan, dia akan ada sensor. Dia ada sensor, dia akan analyze by ECU lah. ECU computer chip tu akan detect. Okey, dia perlu ke tak hidupkan pump. Okey, kalau dia kata okey dah terkunci, tayar kita terkunci, dia pun terus hidupkan pump. So jadilah awak tak tekan tu taklah kunci terus tayar. So brake force applied tu dia akan jadi dia jadi macam impulse, tahu tak? Sekejap ada, sekejap tak ada, sekejap ada, sekejap tak ada. Jadi sebab tu bila kita tekan, kalau ABS tu on, terjalan, teraktif, awak akan rasa brake pedal awak akan naik turun dengan cepat, macam awak bergegar lah, macam tu. So biasanya setakat ni lah kereta yang saya bawa sebelum, kereta saya Honda Civic sebelum ni saya dah jual. Sekarang pakai CX-5, semua ada ABS. Persona pun ada ABS, Persona lama pun dah ada ABS. Tapi setakat ni tak pernah lagi saya terasa aktif ABS. Sebab kalau tak pernah kita tekan emergency, tekan kuat, benda ni awak takkan rasa. Tapi sebab dia active safety system, benda ni akan wujud bila emergency situation berlaku. Jadi kita harap-harap tak pernah berlaku, tapi bila perlukan dia, dia boleh function. Itu penting lah. Okay, untuk safety awak. Okay, jadi ni komponen-komponen dia. Sama juga, kena ada brake caliper, kena ada hydraulic motor tadilah, dan ni dia kena ada modulator dia panggil. Dalam satu case. Jadi yang eksperimen kita dalam lab tu, yang rosaknya bukan rosak pump tu dah repair. Yang rosaknya adalah motor. Tu yang problem dia. Tak boleh nak buat apa, tapi siapa yang dah pernah buat, kira agak-agak boleh faham lah apa macam mana operation ABS yang dalam lab tu sampai sempat buat. Okey. Jadi ni saya skip sebab video tu dah tunjuk. Kalau awak nak baca detail satu-satu, sambil awak refer balik video tadi, okey juga, lagi mudah faham. Okey, saya rasa cukup lah sampai situ untuk kita punya lecture. Sebab lecture ni hanya nak bagi guideline untuk untuk explain lah apa benda ni, semua-semua ni. Tapi yang detailnya untuk jawab test, awak sendiri yang kena hafal, faham. Okey, baca, faham, hafal. Jangan hafal dulu. Okey, baca, faham, hafal. Okey, tu saja, dah habis kita punya syllabus. Dah habislah kita punya MEV321. So sekali lagi saya cakap, semua yang saya letak video-video ke yang simple task kita buat sebelum ni, semua boleh refer balik dalam chapter-chapter ni ya. Okey, dalam Microsoft OneNote. Harap-haraplah pakailah. Kalau saya tahu awak tak nak pakai, saya tak terus buat OneNote ni. Okey. So good luck untuk test, untuk kelas. Kalau ni dah chapter dah habis, awak boleh WhatsApp saya kalau ada problem tak faham ke. Okay, so saya bagi tempoh yang minggu ni untuk awak study balik subjek-subjek chapter yang sebelum ni untuk test kita hari Rabu ni, 18 hari bulan. Okay, Okey, Assalamualaikum, terima kasih, salam sejahtera.